Hi children, welcome to today's class. Today we are going to see exercise 1.2 sums in first chapter. In this exercise, we are going to discuss about two topics. What are that? One is how to represent rational numbers on the number line. Second one is how to find rational numbers between any two rational numbers. About what we are going to discuss here? About two topics. One is rational numbers representation on the number line. Second one, how to find rational numbers between any two rational numbers. Okay, about that only we are going to see here. You know well about number line. Yes or no? What did you say in the previous classes about number line? Numbers on the line is called number line. Clear? In that category, you have seen natural number line, whole number line, integer number line, this and all in the previous classes. See, here natural number line I have drawn here. 1, 2, 3, 4, etc. This is natural number line. A natural number starting with 0. So it is called dash number line, whole number line. 0 is here, right of 0 plus numbers. That means positive numbers. Left of 0, if you extend the number line, it comes negative category. Minus 1, minus 2, minus 3, etc. This line is called dash number line, integer number line. Okay, about this you have seen in the last year itself. Now we are going to see newly rational number line. Clear? How we are going to represent that? Just watch. See now, in this I have taken 0 to 1. Interval I have taken. In this I am going to cut 3 pieces. 1, 2, 3. That means what is the first piece to be represented? 1 by 3. This is out of 3 pieces. This is the first piece. Like that. This, how do you mention here? 2 by 3. Second piece. That means this one 3 by 3. Out of 3 pieces, this is the third piece. Like that. Clear? So, that one can be written as 3 by 3. Now, this is 0 by 3. Can be written like this also. 0 can be written as 0 by 3. See what I did here. I have taken the interval between 0 and 1. I cut into 3 pieces. Clear? That means this piece, the first piece to be represented as 1 by 3. Second piece 2 by 3. Like that, this is the last piece, nothing but 3 by 3. Clear? You can see this as fractional number line also. Yes or no? Last year itself you would have seen like this. Fraction means, what is that? Fraction means part of a whole object. It is represented as two numbers up and down. That number is called numerator. Down number is called denominator. So that and that you have studied in the last year itself. This is fractional number line. Clear? 0 by 3, 1 by 3, 2 by 3, 3 by 3 are dash numbers, fractional numbers. Okay. If you watch closely, what sign indicates here? Positive. Clear? Plus 1 by 3, plus 2 by 3, plus 3 by 3, etc. Clear children? This sign and are not involved in fractional. Suppose sign involves means, how do you tell that line? See here, minus 1 by 3. Left of 0. Left of 0. I have taken interval between 0 and minus 1. Clear? In this, I am cutting into 3 pieces. First piece, second piece, third piece, like that. That means what do you mention? The first piece, left of 0 by 3 minus 1 by 3. That means this one minus 2 by 3. Here minus 3 by 3. Clear children? So such numbers on the line is called dash. Rational number line. What is this? Rational number line. You, just keep it in mind part. Fractional numbers means then just fraction only comes. We are not going to talk about signs there. But rational numbers means fraction with the integers. In the beginning of this class itself, that means beginning of this chapter, I told about definition of rational. Yes or no, what I said? Rational number means the number can be written in the form of P by Q, where P and Q are integers. Q is not equal to 0. Clear? So, rational means fraction with sign. That means integer, plus minus involves. Such number lines are called rational number line. Clear? Here 0 by 3, 1 by 3, 2 by 3. This 1 by 3 onwards, this side positive numbers are coming. Left of 0, minus 1 by 3, minus 2 by 3, minus 3 by 3. These are coming. Actually, what are this? Negative rational numbers. These are positive rational numbers. These are negative rational numbers. This line is called representation of rational numbers on the line. That means rational number line. Clear, children? See, in exercise 1.2, first question is represent the numbers on the number line. What is given here in exercise 1.2? First question, represent these numbers on the number line. See, I have taken that questions in the chart. First question is 7 by 4. What is given here? 7 by 4. See, I have taken here that 7 by 4 on the number line. In which way I have taken? See, I have taken the numbers from 0 to that means positive category. Clear? 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4, 5 by 4, 6 by 4, 7 by 4, etc. Clear? That means what I did here, I cut the interval into 4 parts. Clear? 0 to 4. Actually, here this is 0 to 1. In that, I cut into 4 pieces. The first piece represented as 1 by 4. Second piece 2 by 4. Third piece 3 by 4. Fourth piece only 4 by 4. Nothing but interval, the whole number 1. 0 to 1. In that, I cut the pieces into 4. Clear? Like that 4 to 8. 4 to 8 means which interval comes? 1 to 2. Clear? This is 0 to 1. Here 1 to 2. Second interval. Clear? 1 to 2. In this, again you have to cut the interval into 4 parts because our denominator is here 4. So what comes in that, say the first piece? First 1 by 4 only. But continuously if you see, how comes that 4 by 4 after? The next piece indicates 5 by 4. Next piece 6 by 4, 7 by 4, 8 by 4 and so on. Like this you can extend, or we no need that side. Only we need to represent here which number? 7 by 4. So 7 by 4 we have represented on the number line. Actually what I did, I have taken number line. In that 0 to 1 interval I cut into 4 pieces. After that 1 to 2 interval also I cut into 4 pieces. Why I didn't cut here 5 pieces, 6 pieces, 7 pieces? Why? Because our denominator in the first question is 4. So according to the 4 denominator, I cut into 4 pieces in every interval. At that time 7 by 4 came here. Clear, children? Like that, second question is given in this. What is that? Minus 5 by 6. Actually, what is this? Negative rational number. This we are going to represent on the number line. What we have to do? Watch. Don't consider the sign here. Just to see the denominator of the fraction. What is given here? 6. That means we have to cut the interval into 6 pieces. Suppose denominator 8 means you have to cut the interval 8 pieces. Clear, children? So here question is minus 5 by 6. So I have to cut the interval into 6 pieces. And also minus, negative. So we have to talk about negative side. That means 0. Left side only we have to focus. Right side no needed. Clear, children? So 0 is here. After that, that means left of 0, left hand side of 0, we have to cut the interval into 6 pieces. Clear? In that basis, 0 after first piece indicates minus 1 by 6. Second piece indicates minus 2 by 6. Next one minus 3 by 6. Next minus 4 by 6. After that only minus 5 by 6. Clear? This other we no need. Then what about this minus 6 by 6 become minus 1. So between 0 to minus 1, I cut into 6 pieces. In that minus 5 by 6 is this one. Clear children? In this way only you have to represent the rational number on the number line. Clear? See next question in this. Represent minus 2 by 11, minus 5 by 11 and minus 9 by 11 on the number line. This question also representation of rational numbers on the number line only. Clear? What numbers given here? Minus 2 by 11, minus 5 by 11, minus 9 by 11. These three numbers we have to represent on the number line. See, how do you represent? Clear? Line drawn. If you watch the denominators of the rational, what is given? Number 11. That means what is this meaning here? We have to cut the interval into 11 pieces. How many pieces ma? 11 pieces. And also if you check the signs, what is there? Negative. So negative side we have to cut the interval into 11 pieces. Clear children? So in that basis, how comes? I am taking, that means I no need here positive rationals. Clear? I have to mark these three rational numbers only here on the line. That means I don't want positive side. So I am taking from 0. Denominator 11, no. So the first 0 I am considering as 0 by 11. Clear? That means what comes left side? First piece, how comes? Minus 1 by 11. Clear children? Minus 2 by 11. Minus 3 by 11. 4 by 11. 5 by minus 5 by 11. Minus 6 by 11. Minus 7 by 11. Like that. Continue. Here I can't extend, but in your classwork note you can extend in this itself. I am making here. Clear? 11 after minus 7 after what comes here? Minus 8 by 11. Minus 9 by 11. Minus 10 by 11. Minus 11 by 11. Nothing but minus 1. Clear children? So from 0 to minus 1. Clear? I have taken the interval 0 to minus 1. I cut that interval into 11 pieces because our given question contains the denominator 11. So that I cut this interval 0 to minus 1 into 11 pieces. In that, which three numbers to be marked here? Minus 2 by 11. Where comes? Here, this is minus 2 by 11. Out of 11 pieces, this is the second piece in negative side. Clear? Minus 5 by 11. Where comes this one? So, indicate like this. Minus 9 by 11. Here. Clear children? This is a way of representing rational numbers on the number line. Again, I am telling, here I can't extend the number line continuously. But in your classwork note, you can extend this line in bigger way and make all this in one line itself. Clear? See next, third question, what they are telling. Write 5 rational numbers which are smaller than 2. Write 5 rational numbers which are smaller than 2. 2 is what number here? 2 is the whole number. Less than that, they are asking 5 rational numbers. See, write 5 rational numbers. 5 rational numbers. Five rational numbers which are smaller than 2. Clear? you have to select 5 rational numbers less than 2. So what to do? 2 is the whole number. Less than, that means what comes? 1 you can tell, 0 you can tell. But 5 rationals they are asking, no. So what to do? That 2 can be written as 2 by 1. Clear? Now it is a positive rational number, no? Okay. Less than, that means you can tell here 5 rational numbers which are less than what are that? 2 less than means 1. 1 by 1. It also rational number only. 0 by 1. Yeah. After that negative side. Minus 1 by 1. Minus 2 by 1. Minus 3 by 1. Like this you can continue. Clear, children? The value based comparing to, you have to select 5 rational numbers less than that. Yeah. Comparing to, here 1 is smaller only, value based. 0 is smaller only. All the negative numbers are less than positive 2. Clear? In this basis you have to select. You can select some other rationals also here. Next, fourth question, what they are telling? Find 10 rational numbers between 10 rational numbers. Now only we are going to see the next topic. In the beginning of the class, what I said, we are going to see 2 things in this exercise. One is representation of rational numbers on the number line. Another one, what I said, how to find rational numbers between any 2 rational numbers. What is the second topic I said? How to find rational numbers between any 2 rational numbers. See, for that, if you take whole numbers 7, 9. 7 is the whole number, 9 is the whole number. Between how many whole numbers are there? You can tell. Here is only one number. Clear, children? Negative, integer wise if you take, see, 10, minus 10, here minus 12. In between, how many rational numbers? Minus 11 only. Minus 10 after minus 11, minus 11 after minus 12. Suppose if I ask like this, between what numbers will you take? 7 and 8 are whole numbers. Between that, how many whole numbers are there? Integers. Minus 10, minus 11. Between that, any integer is there. So, in this category, what is your answer? We can take few numbers between natural numbers as well as integers. Definite numbers only. Clear, children? Sometimes, here you can take no number between the given two. Like that. But, if you take rational numbers, if you take 2 rational numbers, see, here 2, here 3. Between that, actually 2 and 3 are basically whole numbers. In this place, what do you say? There is no number between both. But, if we change this whole number as a rational, between 2 and 3, you can take lot of rational numbers. How it is possible? Just now we have proved that there is no numbers between, no numbers means some cases. Some cases few natural numbers are there between 2 whole numbers, natural numbers. Also in integers category, few. In some cases we have proved that there is no numbers. But here I am telling between 2 rationals we can find lot of rational numbers between both. How it is possible? See, 2 can be written as 2 by 1. 3 also can be written as 3 by 1. Now both become rationals. You know it. So 2 by 1, 3 by 1. In between, how many rationals means? Actually, rationals equivalent we can make. Yes or no? See, this 2 by 1 can be written as 20 by 10. Am I correct? Correct only. Clear. 1 10 is 10. 2 tens are 20. 2 we are getting. Likewise, 3 can be written as 30 by 10. 30 by 10. 1 10 is 10. 3 tens are 30. 3 we are getting. So, now this 20 by 10 is equivalent fraction of 2 by 1. 30 by 10 is the equivalent fraction of 3 by 1, nothing but 3. So, without changing that value, we can write them as little bit bigger level. 2 written as 20 by 10, 3 written as 30 by 10. Now, both are equal, you know well. So, between 20 by 10 and 30 by 10, you can take many numbers, no? Yes. 20 after what comes? 21 by 10, 22 by 10, 23 by 10, like that. Up to 29 by 10 you can take. That's all. No, we can extend as our wish. See, I can write this 2 by 1 as 200 by 100. Correct only. I didn't change that value. Just I have expanded the number. But both are equivalent only. See, 100 is 100. 200s are 200. Answer is 2 only. I didn't change that value, ma. Just for my convenience, I have expanded that little bit bigger level. So, 2 can be written as 200 by 100. Both are equivalent fractions only. 3 can be written as 300 by 100. See, value comes equally. 100 is 100, 300s are 300. Nothing but 3 only. Just without changing that value, for my convenience, I am making the number as a bigger level. That's all I did here. In between, you can take lot. 200, here 300. Between how many numbers we can take? So many numbers we can take. 201 by 100, 202 by 100, like that. You can go up to 299 by 100. Between 200 to 300. Clear children? 200 by 100 to 300 by 100. So like this we can extend the numbers by making equivalent fractions. We are not going to change that value. Clear children? So 2 can be written as 20 by 10, 200 by 100, 2000 by 1000, like that. Clear? So if you go like this, if you extend the numbers, we can take lot of rational numbers between any two rational numbers. This is the difference between rational numbers and the previous category, natural numbers, integers. In natural integers case, we can find a few numbers only in between of both. But if you consider the rationals, we can take lot of rational numbers between any two rational numbers. Clear children? Very important 1 mark. What do you say? We can find countless rational numbers. Countless. We can find countless rational numbers between any two rational numbers. Clear? What is the very important 1 mark here? We can find countless rational numbers between any two rational numbers. Clear? About this only we are going to put few sums in this exercise. What is given here? Fourth question. What they are telling? Write 10 rational numbers between minus 2 by 5 and 1 by 2. What is given? 10 rational numbers they are telling. Write 10 rational numbers between minus 2 by 5 and 1 by 2. What to do? Minus 2 by 5 and 1 by 2. Don't consider the sign while solving. Clear? Actually, both are unlike because different denominators, no? Usually how to find here, if they are unlike, you have to take LCM. So as usual, how do you simplify the two fractions? The same way you have to do that. Clear? Finally, we will take 10 rational numbers between. Clear? So, the given rationals are, one is negative, another one is positive. While solving, don't consider their sign. Just to see the fractional wise only the numbers. Here 2 by 5, here 1 by 2. Both are unlike. Unlike means usually what to do for making into like, we have to take LCM of the denominators. What is the LCM of denominators 5, 2? LCM answer is 10 only. Clear? Because both are prime numbers. Prime numbers LCM means their product only. Clear? So LCM of 5 and 2 is 10 only. Clear? LCM of 5, 2 is 10. Clear? Now make equivalent fractions of having the new denominator 10. What to do? Minus 2 by 5 into dash is equal to our new answer 10. What to do? 5 into dash equal to 10. Common factor is here 2 only. So 5 2s are 10. Like that upper side what comes? Minus into plus minus. 2 2s are 4. Minus 4 by 10. Clear children? Like this take this 1 by 2. 1 by 2. 2 into dash equal to LCM answer 10. 5 only common factor. So downside 5 means upper part also by 5 you have to multiply. 1 5 is 5. So we changed both unlike fractions as like this. Minus 4 by 10 and 5 by 10. Clear? See now consider their denominators 10 10. Both are same. That means like fractions. In this moment you can take rational numbers. Clear? Keeping unlike position we can't take. So there usually in 7th standard you have learned to know unlike time how to find the LCM of the denominators and then making equivalent fractions wise. That procedure you have to apply here. Clear children? So here LCM 5, 2 is 10. For getting that 10, I have multiplied the given fractions by the common factors 2 by 2 and 5 by 5. At that time, my answers are minus 4 by 10 and 5 by 10. Now, both are equivalent fractions only. This is equivalent with this. This is equivalent with this. We changed unlike fractions as like fractions. That's all. Sum over? No. What we have to do? 10 rational numbers between these two rational numbers we have to take. What to do for that? Just to make little bit bigger level. That's all. We are not by making the given number into bigger level. We are not going to change that value. Just for our convenience, we are extending the number. That's all. Clear? Copy down neatly in your classwork note. Clear? So how comes we are extending the number now? This minus 4 by 10 can be written as minus 40 by 100. What I did? I have multiplied this number by 10 by 10. I have taken here 10 by 10 for multiple. You can take some other numbers also. Okay, 2 by 2, 3 by 3, 4 by 4, any number. Whatever you wish, by that you can multiply. Clear? So, minus 4 by 10, I changed as minus 40 by 100. What number I have taken? 10 by 10. Clear? Like this. Next number, 5 by 10. Here also, if I multiply this number by 10 by 10, how comes? It becomes 50 by 100. Now, my number is at left side minus 40 by 100. Right side is 50 by 100. Between that, I have to take 10 rational numbers as my base. Clear? So between minus 40 by 100 and 50 by 100, 10 rational numbers means how comes? Minus 39 by 100, minus 38 by 100, minus 37 by 100, etc. Like this, up to plus, actually this left end is minus 40 by 100. Right edge is plus 50 by 100. Between that, we can take lot of rational numbers as our list. Clear, children? So, from this, we can select any 10 rational numbers between the given rationals. So, we can write here, therefore, 10 rational numbers, 10 rational numbers between minus 2 by 5 and 1 by 2 are given rationals I have taken. Clear? Both are equivalent only, no? So, minus 2 by 5 and 1 by 2 between 10 rational numbers means select from this. Minus 39 by 100, minus 38 by 100, then positive wise also up to 50 we have. So, 0 by 100, 1 by 100, 2 by 100, 3 by 100, 4 by 100, 5 by 100, etc. Like the 10 numbers you have to cover. 1, 2, 3, 4, 5, 6, 7, 8. Okay. 49 by 100. Any numbers between them we can take. Okay. This is a procedure for finding any 10 rational numbers between the given two rationals. Clear, children? What I did, first I have changed the unlike fractions as like fractions doing LCM. After that, I made the numbers level little bit bigger because within that position we can't pick up what they asked. The 10 rational numbers means it is not possible. So what I did, without changing that value, just alternately have expanded. Clear? Little bit bigger level. And then we have taken 10 rational numbers. Clear? One more method also is there for finding rational numbers between any two rational numbers. In the next section, I will try another method. Copy down neatly in your classwork note. See, what is next method? See, next section. There also, in fifth section also, there are 3 questions. We have to find 5 rational numbers between them. Clear? Find 5 rational numbers between. First question, 2 by 3 and 4 by 5. 2 by 3 and 4 by 5. Here we have to do, we have to pick up 5 rational numbers. In the first method, just now I tried, no? In which way I tried it? I have taken LCM of the denominators because we have to check first of all both are like or unlike. Like means no problem. LCM work is not necessary. Unlike means we have to find the LCM of the denominators, change into like fraction. Then make the fractions little bit bigger level. Then find out 10 or 5 rational numbers, how much they are asking. There is another method. That means, see, what is that? See, 1 and 2. For example, this is one number, that is one number. Between which number comes means you can tell easily. 1 and half is there. 1 by 1 is a rational, 2 by 1 is a rational number. Between which rational number is there means you can tell 1 and half. Nothing but 3 by 2. This is also rational number only, no? Actually, what is this 1 and half? 1 and half is the middle number of 1 and 2. See, 2 and 3. What is the midpoint? That means middle value of both 2.5. Nothing but 2 and half. Clear, children? Actually, what is that 1 and half, 2 and half, 3 and half, 4 and half? These and all, what are that? The middle number of both. The middle number we can tell as using some other term. What is it? Average or mean. MEAN. About that you have learned in the 7th standard itself. See, 1 and 2. Between which number is there means you can tell 1.5, 1.5 or 3/2. Actually, what is this 1.5? It is the mean of the given two numbers. What is that? Mean. M-E-A-N. Mean or average. Clear? Average of the given two numbers. That other name is mean. About this you have learnt in the 7th standard. Again I am recalling. How do you find mean? You have to add the numbers and divide by that. See here how many numbers are there? Mean means. How do you take? Given numbers are two numbers only. So mean means sum of the two numbers. Sum of the numbers by total numbers. This is the formula. How do you find a mean? How do you find average of the given numbers? You have to add them. That is in numerator place. And then you have to divide that total value by total number. Clear? This is the formula for finding average or mean of the given numbers. Clear children? What is that? Mean of the given values equal to sum of the observations, sum of the numbers by total number of observations. That means total number. Clear? Here what numbers given? 1 and 2, no? So 1 plus 2, sum by total. How many numbers are there? Just two numbers, 2. So 1 plus 2, 3 only, no? 3/2. Nothing but 1.5. Clear? This is the procedure for taking average of any numbers given. Clear? What is the formula? Sum of the numbers by sum of the observation by total number of observation. Observation nothing but given values. Like using this way only, we are going to find many rational numbers between given two rational numbers. This is the next method. Clear? In general, how we can say for any two rational numbers a comma b, a plus b by 2 formula. The middle number a plus b by 2 such that a is less than a plus b by 2 less than b. Clear? See here 1, here 2. A value is 1, b value is 2. Between them, which is there? The mean, nothing but average. Here 1 and 2, between we can take 1.5. Clear? That is a plus b by 2. Sum of the observations by total number of observations. So using this mean formula a plus b by 2 also we can find between any two rational numbers. Clear? In this method only I am going to solve this sum. Okay. So here a value 2/3, b value 4/5. So between in between of a and b, I have to take numbers means which formula I can use? Mean formula. What is that? Nothing but average. Mean formula. What is that? A plus b by 2. Clear? Here a value is 2/3. B value is 4/5. Divided by 2. Divided by 2. A plus b by 2. Clear? Addition of unlike fractions. Usually that fraction work, how we solved it in 7th standard, the same procedure you have to apply here. Addition of unlike fractions. Immediately what to do? LCM work only. LCM of the denominators 3, 5 is 15. Why? Because both are prime numbers. Prime numbers means what is that LCM? Their product only. Here 3 and 5 are prime numbers. So their product only is its LCM. Clear? So LCM is here 15. 15 what means? By which I have to multiply the first fraction. 3 into dash equal to 15. By common number 5. 3 5s are 15. Downside 5 means upside also by 5 only I have to multiply. So 2 5s are 10. Plus, likewise here common factor is 3. 5 3s are 15. So that 4 3s are 12 comes in upper part. divided by 2. Now 10 plus 12, 22 by 15 now divided by 2. The 2 can be written as 2 by 1. Clear? Addition of unlike fractions. Doing LCM wise, I got this step 10 by 15 plus 12 by 15. What is this answer? 22 by 15. Clear? 22 by 15 divided by 2. 2 can be written as 2 by 1. Division of two fractions is the reciprocal of multiplication. You learned that. So 22 by 15 multiplied by this reciprocal 2 by 1 becomes 1 by 2. Clear? Simplify. 1 2 is 2. 11 2s are 22. So answer is 11 by 15. Clear? A plus B by 2 value is here 11 by 15. Clear children? So we can write here A is 2 by 3 less than, what is A plus B by 2 value? 11 by 15. It's less than, what is B value? 4 by 5. Clear? So A is given number 2 by 3, B is 4 by 5. Between them, how I found first number means using the mean formula A plus B by 2. In which way means, first of all you have to add the numbers and then divide by 2. At that time you are getting answer 11 by 15. Like this only you have to select another 4 rationals also. At that time how do you take this as the first one, this as the second one. That means A, B. Between them take A plus B by 2 value. Like that side also we can take. Clear children? This is second method. If you feel this as difficult, you follow the first method itself. Clear? Copy down neatly in your classwork. So here 2 by 3 and 4 by 5. Between that we got 11 by 15. One number, one rational number. Using this formula we got it. Clear? They asked 5 rationals, no? So it takes time. Using this formula if you go, takes time. So better for understanding purpose, I taught this method also. Easily want to complete means making equivalent fractions ways, we can take quickly the answers. Clear? So one number only we found, no? Remaining 4 rationals we have to find. So what I am going to do in the first method itself. Clear? For understanding purpose, I taught this method also now. Clear children? You can continue in this, but it takes time little bit comparing the previous method. So I am trying by the first method itself. Clear? So in which way we can try for the first method? What is the procedure? First of all, we have to take this, find the LCM of both. At the time what comes? I don't know. 2 5 LCM if you take means here how comes? LCM 15 only. So 2 5 are 10 by 15 comes here. Here 3 4 are 12. 12 by 15 comes. Okay. Change the unlike to like using LCM wise. In between I have to take 4 more rational numbers. Already 1 we found. Here 10 by 15, 12 by 15 means in middle 11 by 15 only. Already got it. What to do? So I am going to extend that. By which way? By 2 by 2, by 3 by 3, by any common number I can multiply. Here I am taking 10 by 10. So 10 tens are 100 by 15 tens are 150. Like that 12 by 15 can be written as by multiple 100 by 100. What comes? Sorry, 10 by 10. 120 by 150. I made the 10 by 15 as 100 by 150. 12 by 15 as 120 by 150. In between, I can take 4 rationals as my wish. 101 by 150. 102 by 150. 103 by 150. 104 by 150. Clear? Already we found what is that? First rational 11 by 15. Clear, children? So 5 rational numbers between 2 by 3 and 4 by 5 means we can select like this. What are that? 11 by 15, comma, 101 by 150, 102 by 150, 103 by 150, like this. You can take some other factors also. Here for my convenience, I have taken 10 by 10. You can take 2 by 2 also, 3 by 3, any number as your wish you can go. Like this is a procedure for finding few rational numbers between given two rationals. Okay. There are two methods, children. First method, extending the number like this. We can go. Second method means mean formula. What is that? A plus B by 2. Our mean other name is average. A plus B by 2 method we can find it. But it takes, using that formula, if you solve, it takes little bit extra time. So that method also I told, which is easy to follow. In that way you continue the remaining sums. Okay, children? That's all. 6th and 7th question also this way only. What they are asking, write 5 rational numbers greater than minus 2. Greater than minus 2 means minus 2 is the negative number. Greater than means how we can go? Minus 1, 0, plus 1, plus 2, plus 3, like that you can go. Rational wise you have to write. That's all. Minus 1 by 1, 0 by 1, 1 by 1, like that. Anyhow, you can select as your wish. Write 5 rational numbers greater than minus 2. 7th question, find 10 rational numbers between 3 by 5 and 3 by 4. Like this only they are asking. Try yourself. Okay, children? That's all. Exercise 1.2 sums over. Based on this, worksheet will come. Take practice. Thank you.